Hello everyone, welcome to today's lesson on creating tree diagrams. Alright, so something new that we haven't done before, but we'll spend in the next few lessons looking at this, okay? So hopefully it'll make a lot more sense once we've gone through this, alright? So creating tree diagrams. So first thing we need to understand is what is a tree diagram, okay? So we're talking about probability. So a tree diagram shows all the possible outcomes of two or more events happening, okay? It shows these by using paths or branches that could be followed. Okay, so we usually call them branches, which is why we call it a tree diagram, because obviously trees have got branches. All right, there's two things that we need to understand, and this will be a lot more clear as we go through the examples and as we progress through the next few lessons on probability tree diagrams and how to draw them and how to use them. Okay, so in probability, the word "and" means the probabilities are multiplied. Okay, so when we go across the branches on the tree diagrams, we're always going to be multiplying. Okay, and the word "or" means the probabilities are added, and that's usually if we're going down the diagram. Okay, so "and" is always multiply. Okay, and that is when we're going across branches. So anytime we're going across branches, which will make more sense once we've done the examples, of course, whenever we're going across branches, we're always going to be multiplying because we're using the "and" rule. Okay, and whenever we're going down the branches, that is using the "or" rule, so that means we're going to add. Okay, so a tree diagram shows possible outcomes of two or more events happening using branches. Okay, so you might want to pause and just jot down anything that you think is important there, and then just press play when you're ready to move on. Okay, welcome back. And so the first example, I haven't given you a lot of information here, but just press pause and write this down. Press play when you're ready to see how it's done. Okay, so James flips a fair coin twice. Draw a probability tree diagram and show all the possible outcomes. Okay, so the way that we do this is because he's doing it twice, okay, our first set of branches will be talking about the outcomes the first time he does it. And then our second set of branches will be talking about the outcomes the second time he does it. Okay, so the first time, okay, so let's say first flip, okay, there are two possible outcomes, aren't there? Okay, so we're going to do two branches. So the first flip, the two possible outcomes are that he'll get a heads or he'll get a tails. Okay, that's the only thing that's going to happen, isn't it? Okay, he's going to get a heads or he's going to get a tails. Then the second flip, okay, it's still the same thing, isn't it? He's still got a chance of getting a heads or a tail. So what we do here is he could get a heads of the first time. Okay, you do two branches from heads now because the second time he does it, he can still get a heads or he can get a tails. Okay, and if he had got a tails the first time, he's still either going to get a heads or tails second time. All right, so probability tree diagrams will always start off looking like this if we're talking about two different events, which we are. We're talking about the coin being flipped twice. Okay, so we're saying this is the first flip, you can either get a head or tails, and this is the second flip. Okay, so if he gets a heads first, he can still get heads or tails the second time. If you get tails first, he can still get heads or tails the second time. Okay, so you'll get a lot more used to drawing these the more that we do it. Okay, we now need to put the probabilities on these branches. Look, so these branches that we've drawn, that's where we write our probabilities. And this is quite a simple one to start off with if you think about it. Okay, we're not given any numbers in the question. Sometimes we are. In this particular example, we're not. Okay, but remember, this branch here is the probability of getting a heads. So hopefully you can figure out if you flip a fair coin, then the probability of you getting a heads is 1 out of 2, isn't it? Because remember, when we do probability, it's always the number of ways of getting what we want divided by the total possible outcomes. Okay, so it's how many ways we can get what you want divided by the total possible outcomes. All right, and we've covered probability in previous lessons anyway. So the probability of getting a heads, well, there's 1 heads out of 2 possibilities, isn't there? So there's a 1 in 2 chance of getting a heads. That also means that there's a 1 in 2 chance of getting a tails as well. Okay, and something that we've learned before is all probability. Okay, all probability adds to 1, doesn't it? Because the probability of something that's got a probability of 1, means that it's certain to happen, and you can't get anything more than certain, can you? So one thing to bear in mind when drawing these diagrams is each set of branches has to add up to 1, okay? Because probability adds up to 1, doesn't it? So you can either get a heads or you can get a tails. There's nothing else that can happen, okay? So there's a 1 in 2 chance of getting a heads in the first flip. There's a 1 in 2 chance of getting a heads in the second flip, okay? So that goes there as well. That goes there, that goes there, that goes there. Because think about it, right? On the second flip, we're still using the same coin. So whether you got heads or tails in the first flip, that doesn't affect the probability in the second flip, does it? Because it's still a 1 in 2 chance. Okay? So we've drawn the probability tree diagram, okay, and we filled these gaps in with the information that we need. So there's a 1 in 2 chance of getting a heads first and second time. Okay, there's a 1 in 2 chance of getting a tails first and second time. So all of the probabilities are 1 in 2. Where we say then show all the possible outcomes, okay, that just means use the diagram to list the outcomes at the end, okay? So our first outcome is by following these first 2 branches, look. So the first outcome we can see on here is you get a heads, James will get a heads in the first flip and a heads in the second flip. So we're just going to write H and H here for heads and heads. Okay, so the probability that he gets a heads the first time is 1 out of 2. So I'm going to write that down, look. And the probability that he gets a heads on the second flip is also 1 over 2. And remember I said earlier on, when we go across the branches, look, which is what we're doing here, we're going across this one and then across this one, it's the AND rule. So that's always multiply. So we're saying here that he gets a heads the first time and he gets a heads the second time. So because it's the AND rule, and because we're going across the branches, we're going to multiply. Okay, so we're going to do 1 over 2 multiplied by 1 over 2. So remember, multiplying fractions together is simple. You just multiply the top 2 numbers and the bottom 2 numbers. Okay, so 1 times 1 is 1, 2 times 2 is 4. So that outcome is 1 over 4. Okay. And we just need to do the same for the others then. So the next outcome, if you do them in order, okay, the next possibility is James will get a heads on his first flip here, but he'll get a tails on his second flip. So we would write here H and T for heads, then tails. Okay. Hopefully you'll note this now. The reason this is an easier one to start with is all the probabilities are the same. So this is still going to be 1 over 2 times 1 over 2 because it's a 1 over 2 chance of getting a heads, look, and then a 1 in 2 chance of getting a tails. So that's 1 over 4. Okay. The third possibility now is we've done the 2 where it's heads first. The next one is that he gets a tails first and then a heads second. So tails, then heads. So 1 over 2 times 1 over 2, which is 1 over 4. All right. And the last possibility now is that he gets a tails on the first flip and a tails on the second flip. So tails and tails. 1 over 2 times by 1 over 2. Okay, so it's not always going to be this case where everything's the same, all right, but this is just an easier one to start off with. So we draw a branch, or we draw a pair of branches, sorry, for each outcome, and we write the probabilities down, and then we do the same thing for the second outcome, write the probabilities down, and then when we list these outcomes at the end here, then it's always going to be by going across the branches in pairs. Okay. So I'm gonna do another example with you anyway before I give you some to have a go at yourselves. All right, and don't worry if it's a little bit confusing at the moment. It is something new, but it will make sense over these next few lessons the more practice that you get. So next one then. Copy this one down, please, and then press play when you're ready to draw the diagram. Okay, welcome back. So this says Helen passes through 2 sets of traffic lights on her way to work. The probability that she stops at the first set is 0.3. The probability that she stops at the second set is 0.2. Draw a tree diagram and show all the possible outcomes. Okay, so we're talking about 2 sets of traffic lights. So we've got 2 sets of branches in there. So in the first set of traffic lights, okay, got our 2 branches. And our 2 possibilities are she's either going to stop at the traffic light, okay, or she's not going to stop. So I'm just going to write S for stop and NS for not stop. Okay. On the second set then, okay, we're still talking about the same thing, aren't we? So once she has past the first set of traffic lights, because it says here, look, she passes 2 sets. On the second set of traffic lights, it's still the same possibilities, isn't it? She's still either going to stop or she's not going to stop. She's either going to stop or she's not going to stop. Okay, so that's what the diagram will look like, and now we can fill the information out. But this one is not as simple as the last one, because you need to be careful with the information in the question. So this sentence here, look, says the probability that she stops at the first set is 0.3. So there's a 0.3 chance that she will stop at the first set of traffic lights. So 0.3 must go there. Okay. And now before we look at the second set, we need to fill this part out, don't we? Because remember now, each set of branches needs to add up to 1. Because these are the only things that are going to happen at the first set of traffic lights, isn't it? She's either going to stop or she's not. So if there's a 0.3 chance that she will stop, hopefully you figured out that there's a 0.7 chance that she will not stop, because those two numbers add up to give you 1, doesn't they? So if you want to work this out, if you don't understand, just do 1 minus 0.3. Okay, 1 minus 0.3 gives you that 0.7. All right. The next sentence here, though, look, gives you the possibilities for the second set. So it's not going to be 0.3 and 0.7 again now, because this part here says the probability that she stops at the second set is 0.2. So that must be 0.2 there, okay, which is obviously the same there as well. So the probability that she stops in the second set of lights is 0.2. If there's a 0.2 chance that she stops, there must be a 0.8 chance that she doesn't stop, because those pairs of branches now, they will add up to 1, won't they? Okay, so once we fill the diagram out completely, including the probabilities, and obviously this time I'm giving you them in decimals rather than fractions, but it's the same sort of thing. So we're still going to get 4 different outcomes now across these 2 sets of lights. Okay, the first outcome is that she stops at the first set and she stops at the second set. So that's just following these 2 here. Look, she stops first and she stops second. Okay, so there's a 0.3 chance that she stops first. There's a 0.2 chance that she stops at the second. And we know now we're going across the branches, aren't we? It's the AND rule, so we're multiplying. And be careful with this, all right? So many people write 0.6, but the actual answer is 0.06, isn't it? There's 2 decimal places in the question, so there has to be 2 in the answer. All right, so 0.06. Okay, the next possibility then is she stops at the first set and she doesn't stop at the second set. Okay, look at the information. There's a 0.3 chance she stops first. There's a 0.8 chance that she doesn't stop in the second set. So we times those together now, which is 0.24. Okay. Third outcome then, so we've done the outcomes where she stops at the first set. Let's now do the ones where she doesn't stop at the first set. Okay, so the next outcome is she doesn't stop at the first set of lights, but she does stop at the second set of lights. So there's a 0.7 chance she stops at the first set. There's a 0.2 chance that, 0.7 chance that she doesn't stop at the first set, and a 0.2 chance that she does stop at the second, so that's 0.14. And then the only other possibility that we haven't covered is that she doesn't stop at the first set and she doesn't stop at the second set, so she stops at neither of the sets. Okay, so the probability of her not stopping the first time is 0.7. The probability of her not stopping the second time is 0.8, and we just times those together. Okay, I didn't say this last time because all the numbers were the same, so it was obvious, all right? But it's really important that not only these pairs of branches add up to 1, but these outcomes add up to 1 as well. Because these 4 outcomes that we've just listed are the only 4 things that can happen. Nothing else can happen in this situation. So these 4 answers here at the end, they also need to add up to 1. All right, so if you're unsure about any of the steps or you think you may have done one wrong, always double check the outcomes at the end. Okay, if we add these outcomes together, now they do give us 1, so that's telling us that we've done it correctly. Okay, so make sure you've got both of those examples written down to help you now, and I'm going to show you the main task. Okay, I just want you to try and do a similar sort of thing. You've got those 2 examples written down then to refer back to now. does take a bit of getting used to. All right, so here are the 4 questions that I would like you to try now. So I'm giving you all the information that you need, okay? You need to try and draw the tree diagram for each of these and then list the possible outcomes as well. All right, so press pause, copy these down, have a go, and then press play when you're ready to go through the answers, because I'm going to do each one separately just to make sure that we all understand why the answers are what they are. All right, so press pause, have a go, press play when you're ready. Okay, welcome back then. So the first question, all right, so this is what I did for the first question. All right, so it says the probability that Rico is late to school is 0.7. Draw a tree diagram and show all the possible outcomes over 2 days. So first day, look, he can either be late or he's not late. There's no in between, is there? I'm telling you here that there's a 0.7 chance that he's late, so there must be a 0.3 chance that he's not late. All right, then on the second day, the probabilities are the same. It's still 0.7 for late and 0.3 for not late, and then the same underneath as well. All right. Then the outcomes, just by forming the branches again, look, so it's late on the first day, late on the second day. Okay, so times the probabilities together. Second outcome is late the first day, not late the second day, and then so on. You can see the others, all right? And then if you add these numbers together at the end, they make 1. So that's the first answer, okay? So press pause if you need a little bit longer to have a look at that and copy it down if you need to. And then press play when you're ready for question 2. So question 2 then, a bag of buttons contains milk and white chocolate. The probability of getting a milk chocolate button is 3/5 or 3 out of 5. Draw a tree diagram and show all the possible outcomes when picking 2 buttons. Okay, so we're talking about when picking 2 chocolates, sorry. So we're talking about 2 different picks. So on the first pick, you can either get a milk chocolate button or you can get a white chocolate button. Okay, I'm telling you here, look, the probability of getting a milk chocolate is 3 out of 5. So the probability of getting a white, because that's the only other thing that's in there, must be 2 out of 5. So that pair of branches adds up to 1. The second pick then is exactly the same probability. Okay. From there, you list your outcomes, you multiply your fractions together. Okay. That's how you would do that one. So again, press pause if you need a little bit longer to look at that. Press play when you want to go through question 3. Welcome back then. So question 3, this one takes a little bit more thinking now. So Jim and Sue each take a driving test. The probability that Jim will pass is 0.7 and the probability that Sue will pass is 0.6. Draw a tree diagram and show all the possible outcomes. Okay, well this time, the 2 different sets that we're looking at is Jim passing or Sue passing. Okay, so Jim will either pass or he'll fail. You can't have in between, can you? Either pass or fail. I'm telling you here, look, there is a 0.7 chance that Jim will pass. That must mean there's a 0.3 chance that he won't pass. All right. The second set of branches then is to do with Sue passing. And remember, this can be done the other way around as well. So you could have put Sue first and Jim second. It wouldn't change your answer. Okay. I'm telling you in the next part of the information that the probability of Sue passing is 0.6. So there must be a 0.4 chance that she doesn't pass. Okay, so whether or not Jim passes the first time doesn't have an effect on whether Sue passes, and whether or not Jim fails doesn't have an effect on whether Sue passes or fails. Okay, and each pair of these branches adds up to 1, doesn't it? Then you list your outcomes and multiply the numbers together. All right, and again, these 4 outcomes at the end, they're the only things that can happen, and they add up to 1. All right, so again, pause if you need a little bit longer to look at that one. Press play when you're ready for question 4, please. Welcome back then. So last one here, the probability that Bruno Fernandes scores in a game is 7/20. Draw a tree diagram and show all the possible outcomes for the next 2 games. So in the first game, he will either score or he won't score. So he scores or he doesn't score. There's no in between, is there? I'm telling you, there's a 7/20 chance that he scores. There must be a 13/20 chance that he doesn't score, because that needs to add up to 1, doesn't it? Or in this case, it needs to add up to 20/20. This is the second game then. All right, and it's exactly the same thing, isn't it? It's still 7/20 chance he scores, still 13/20 that he doesn't score. So you fill that in, you list your outcomes again, right? Just following the branches, multiplying. So we get 4 different outcomes at the end here. Those 4 still add up to 1 because they add up to 400 out of 400. Okay. Right, the checking question then. All right, so I just wanted to fill the diagram out for this one and just list the possibilities. All right, so press pause, copy this down, press play when you're ready to go through the answer or to check your answer. Okay, welcome back then. So I'm just going to fill this in now. All right, so just made it a little bit bigger on here. So it says that he's playing a game of chess, I believe. Let me just check. Yeah, Jane's playing 2 games of chess. Okay, so in the first game, she can either win, or she can draw, or she can lose. Yeah, if there's a 0.2 chance that she wins and a 0.3 chance that she draws, hopefully you wrote 0.5 there because these 3 together need to add up to 1. So just because there's an extra branch, they still need to add up to 1. All right, so these 2 here give you 0.5, so that must be 0.5. Which means whatever is on the first set of branches now is the same on the second sets as well. Okay, the probability of her in the second game is exactly the same as the first. So we should have 0.2, 0.3, and 0.5 on all of these. So 0.2, 0.3, 0.5, 0.2, 0.3, 0.5. Okay. So when it comes to doing our outcomes now, obviously there are more outcomes this time than there were in the previous questions, but just do each one's separately. So the first outcome, just follow the branches logically, is that she wins the first game and she wins the second game. So win-win. Okay, that's 0.2 times by 0.2, which is 0.04. Yeah, not 0.4. There are 2 decimal places in the question, so 2 in the answer. Okay, and just follow that in order then. So the next probability is that she wins the first game but draws the second game. So that was 0.2 times 0.3. That's 0.06. The next possibility is she wins the first game but loses the second game. So that's 0.2 times 0.5, which is 0.10. Okay, so they're all the probabilities there of her winning the first game. All right, those 3 there. The next set now is her drawing the first game. So she can draw the first game and win the second game. So draw the first, win the second. Okay, so that's 0.3 multiplied by 0.2, which is 0.06 again. The next thing is she can draw both games. So she can draw the first one and draw the second one. So 0.3 times 0.3 is 0.09. Next one in order now is she draws the first game, but she loses the second game. So draw and then lose is 0.3 times 0.5, which is 0.15. Okay, and they're the 3 possibilities there, look, of her drawing the first one. So the last 3 now is when she loses the first game. So she can lose the first game and win the second game. Okay, that would be 0.5 times by 0.2, which is 0.10. She could also then lose the first game but draw the second game. So lose then draw. That's 0.5 times 0.3, which is 0.15. And then the last possibility is she loses both games. So lose is 0.5 multiplied by 0.5, which is 0.25. So well done if you've got any of those possibilities right, because it's quite a tricky one there. Although there's nothing different to do, it just takes a little bit longer and it's easy to make a mistake. I would still suggest adding these numbers up here at the end to make sure that they make 1. Okay, but that's how you would do that one. Okay, and if you're still a little bit unsure, don't worry, there's still another 2 lessons coming up on not only creating probability trees, but also using them to work out some answers to some questions as well. So you'll have plenty more practice over the next couple of lessons, okay? But that's it for today's on creating probability trees. Thanks very much.